Circadian rhythms, metabolism, and nutrition are intimately linked, although effects of meal timing on the human circadian system are poorly understood. We estimated the effect of a 5 hours delay in meals on markers of the human master clock and multiple peripheral circadian rhythms. 10 healthy young men undertook a 13-day laboratory protocol. 3 meals, breakfast, lunch, dinner, were given 5 hours intervals, beginning either zero point 0.5 early or 5.5 late hours after waking up. Participants were adapted or acclimate. Fuck, I know the meaning of that word, but I'm struggling to pronounce it. Acclimated. Yes,
Automated.
acclimated, yeah, to early meals and then switch it to late meals for 6 days. After each
What
meal
the
is
what the wait. They had a fucking 15-hour feeding window.
no, I didn't read that.
Well, you said that they had 3 meals with 5 hours in between meals, or is it 10 hours?
No. They had like 5 hours intervals, and the beginning either 0.5 on early, and like late was 5.5 hours after waking up.
So what's the total feeding window
I just told you.
in hours?
Uh,
I mean, how many hours was their feeding window altogether?
um, the feeding window. Let me check.
That'd be 10. Would that be 10 hours if they had 3 meals with 5 hours in between?
1 second. Uh, it doesn't like specifically say that. It just says like 0.5 early or 5.5 late hours after waking up.
Well, you said they had 3 meals.
Yeah, yeah.
Okay, so that's important.
And it was like within like intervals of 5 hours.
So if there's 3 meals and there's five, so breakfast starts in 5 hours later lunch, and then 10 hours after breakfast dinner. So that's 10 hours. Within 10 hours, 3 meals, right?
Yeah, yeah. I
So
mean,
so their feeding window was 10 hours.
but isn't it like 5 hours intervals, like within like a space of 5 hours? Isn't that what it means, or am I mistaken on what intervals mean? Like a
So
gap, like
so maximum. So the maximum would be 5 hours, right? So the maximum feeding window would be 5 hours from breakfast to lunch and 5 hours from lunch to dinner, which is, if you use maximum, it would be 10 hours maximum, right?
I guess so. Yeah,
Yeah,
yeah.
I mean that's still shorter than usual. Let's say that's a pretty good fucking feeding window. And then you said what about the after wake up?
Um, like basically, we're given at 5 hours intervals. Beginning, it was either at 0.5, which will be like 50 minutes early, or 5.5. 5 hours and 50 minutes late hours after waking up.
Oh, oh. Well, 0.5 would be 30 minutes.
Oh, okay.
It's half half an hour, right?
Okay,
Zero
okay.
point 0.5 of an hour, half
Okay,
an
so it
hour.
will be
Okay.
like 30 minutes or 5 hours and 30 minutes at late.
Nice, nice. Okay.
Okay, and then participants were acclimated to early meals and then switched to late meals for 6 days. After each meal schedule, participants' circadian rhythms were measured in a 37 constant routine that removes sleep environmental rhythms while replacing meals with hourly isocaloric snacks. Any doubts about that?
Yeah, I didn't catch that. Maybe read it again. Maybe I'll catch it the second time.
Okay, okay. Let me read it. Participants were acclimated to early meals and then switched to late meals for 6 days. After each meal schedule, participants' circadian rhythms were measured in a 37-hour constant routine that removes sleep and environmental rhythms were replacing uh, and environmental rhythms while replacing meals with orally isocaloric snacks.
What?
Yeah,
So
like
so after they finished their 6 days of particular meal, then they had 35 hours of testing, right?
yep. And like
And
isocal
during those 35 hours or so,
and by the way, the
they
isocaloric snacks is basically like snacks that have like the same like calorie value and properties. Like they were giving like the same snacks basically with like the same like protein, carbs, vitamins, whatever. Yeah.
um do you know what, like, why weren't they just given the same meals? Like, why replace the meals with isocaloric snacks?
No clue.
So they had this 35 hours or so of testing,
Mm-hmm.
during which they ate on the same schedule as before, or was it different schedule?
Currency were measured as while replacing meals with early uh no, it you know doesn't say. I could take a look at the study if you wanted me to, like for
Yeah,
yeah. Even if it says, I'll
as
tell
a
you.
question. Yeah, as a question. Yeah, that. Um, then let's see.
Can you repeat the question so I
But
can
so
write
so
it down so I can get like a concrete uh answer? I mean, question or response out of it.
did they eat on the same schedule as before, or how did their schedule of eating during the 35 hours of testing change or didn't change from the 6 days?
Okay, changed or didn't change. Okay, I wrote it down. Okay, so participants' circadian rhythms were measured in a
But wait,
what?
wait, wait. But so apart from that, they didn't eat the same food though, right? As before, they just fucking ate snacks for 35 hours.
I mean, what implies here that after replacing like meals, right, with hourly psychocaloric snacks, yeah, I guess so. They replaced their meals kind of with like snacks that had the same properties for 37 hours.
Yeah, that makes no fucking
Well,
sense. Yeah, if you can look into it.
I mean, this is
What?
what I got. Like, listen, circadian rhythms were measured in a 37 constant routine that removes sleep and environmental rhythms while replacing
You said
meals.
wait. You said 37 hours.
Yes, and
Okay.
they replaced their meals with hourly isocaloric snacks. Like each, they were giving them like snacks every hour. I guess that's what hourly isocaloric snacks mean. I guess. So I guess kind of mean.
Or-
I feel like what implies there is that like for 37 hours they were like giving them hourly like snacks that had the same value for them to fucking eat. While they were like testing them.
every hour.
I mean, it says hourly.
Are you there?
Yeah, yeah. Can you hear me?
Yeah. That is super weird, right? What
Yeah.
the
I
fuck?
mean, I feel like
They just gave them snacks every hour.
yeah, I feel like we just literally. I mean, we just answered the question that you asked me. I mean, basically, I think. They were giving
Well,
them.
but I mean, is it every hour for what in what window? I'm guessing it's not 24 hours. They gave them every hour
I mean,
snack. Like
d- d-
had to sleep.
it uses 37 hours of constant routine that removes sleep and environmental rhythms while replacing meals with daily isocaloric snacks. So, I don't know, maybe this was some sort of like torture chamber experiment where they kept them alive for 37 hours and they fed them a fucking snack every fucking hour. Like they're
Damn.
falling asleep.
Wow.
They fucking like whip them in the fucking bag and they shove the fucking snack into their fucking mouth.
Right.
Eat, fucker, eat.
Wow. Maybe this is like a study from like 1920s on slaves to see how long slaves could fucking work.
Yeah. uh, maybe,
But
maybe.
but I mean, so it kind of sounds like they literally kept them awake for 37 hours.
Yeah, yeah. And they gave them hourly snacks. That's what it says. Isocaloric, which means that, same carbs, same properties.
Yeah, if you can double check on that as a question, like
Yeah, for
I don't
sure.
know, look into
Yeah,
it
yeah,
and
I
double
will.
check it, because that sounds like very very different from what one would expect.
Yeah.
Okay, yeah, okay, let's go.
Um, Meal timing did not alter actigraphic sleep parameters before circadian rhythms measurement. In constant routines, meal timing did not affect rhythms of subjective hunger and sleepiness. Master clock markers, or plasma melatonin and cortisol, plasma triglycerides, or clock gene expression.
Wait. I mean, so they measured their sleep metrics,
Yeah,
some type of sleep metrics, and they said that those sleep metrics were not affected, right?
yeah.
So what?
It says meal timing did not affect rhythms of subjective hunger and sleepiness.
Sleepiness. But
Yeah.
but they also measured other metrics of sleep, like actual sleep.
I don't think so.
Oh, I thought you read something about that. Can you reread it?
Okay, okay. Meal timing did not alter actigraphic sleep parameters before circadian rhythm measurement.
What does that mean?
That like what I get out of it or I got out of it is still like the meal timing did not like fuck up with like their sleep schedule.
Oh, so you think that they're comparing their sleep
With like the meal timing,
metric
yes,
during
yes,
during the 6 days of one meal timing versus the sleep metrics during the meal time of the other 6 days.
yep. What I'm getting is that basically, since they modified or they changed their eating habits, eating schedule, they tried to look whether it affected their sleeping schedule, and apparently it did not. It says before circadian rhythm measurement.
Okay.
Yeah.
If you before circadian rhythm measure, which you think is the 37 hours test,
Yeah.
the circadian rhythm measurements would be, you think that they're talking about the 37 hours.
Yeah. Yeah.
So if you can open that study and like control F, uh, poly and type in polygraph, see if there's any mention of a poly. I think it's called polygraph.
Yeah. Yeah. I'll look it up when we finish this podcast.
Oh, okay. I didn't know if you had that study handy to like just control F
No.
and
No.
see
No.
if
Not. Not really.
Okay, that's fine. Yeah. If you can see what kind of um like how did they assess the sleep, during the 6 days of one diet versus the sleep during the 6 days of other diet? Like, how did they look? How did they compare it? Like, what
Okay.
metrics did they use? Okay,
Yeah.
cool. So the sleep quality and the hunger levels didn't get affected, which is insane, right? Like,
Yeah.
if you eat breakfast every day and then suddenly you have to fucking not eat breakfast.
Yeah. Meal
when she
time,
gets hungry.
yeah, meal timing did not affect rhythms of subjective hunger and sleepiness. Master,
Maybe it's on a sixth day.
yeah.
Like
Uh,
after you get acclimated to the new schedule, maybe after that, like on a sixth day, like they weren't hungry compared to the other um, case. So on
mm-hmm.
the sixth day of one test, they weren't any more hungry than on the sixth day of the other test once they got used to it.
Yep. Uh, mm,
You
uh,
think uh, you
huh?
think that's what happened?
I believe so. Yeah. I mean, your
If you can
explanation.
check into that as a question.
Yeah, I will.
Like when did like hunger on what day did they compare? Was it like the hunger on the sixth day, or was it like average hunger on every day?
Yeah. Okay. I'll look. I'll check up on hunger and when was it like analyzed within what day?
Yeah, yeah, like because you would expect like on the first day you would expect them to be very hungry if they suddenly didn't have breakfast,
Yep.
but
Uh,
maybe on the sixth day they got used to it.
that's true. Master clock
Okay.
markers, plasma melatonin, and cortisol, plasma triglycerides, or clock gene expression in white flow. I mean, gene expression in whole blood following late meals. However, glucose rhythms
Hey,
were.
another question for you. Can you see like I feel like somewhere in the study they would say exactly why they decided to keep them awake for 37 hours,
Yeah,
like why
yeah,
they thought that was the best idea to test it. See if you can find explanation for why they did that
yeah,
in the
yeah.
study.
To keep them
Okay.
awake for 2 hours.
Yeah.
Yeah, okay.
Why they chose to keep them awake for 37 hours?
Okay, for sure. I'll look it up. Also, I will, triple check on the study, but like there is, I bet that there is some things that it might they might not be there, but I'll try to get the most information out of it.
Yeah. Yeah. See if it's there.
Yeah, yeah. And even if it's not there, I don't know, I'll try to look for the same study, maybe in a different source, and maybe it has more details. But yeah, what I was gonna
Yeah.
say.
Yeah. Or just think about it. Maybe you can figure out, even if they don't say it, maybe you can figure out why they thought that would be a good idea.
Yeah, yeah, I'll try to figure out if there is any hints.
Your
Um,
best guess.
yeah, yeah.
Yeah.
Um, okay, so basically, meal timing did not affect rhythms of subjective hunger, sleepiness, master clock markers, plasma melatonin, and cortisol, plasma triglycerides, or clock gene expression in whole blood. Following late meals, however, plasma glucose rhythms were delayed by 5.69 um, uh, n- fucking what is it called?
Plus minus.
Plus minus, yes, plus minus 1.29 hours, and the p-value was lesser than 0.001, and average glucose concentration decreased by 0.27.
Wait. Can you repeat that sentence?
Plasma glucose rhythms were delayed by 5.69 plus minus 1.29 hours,
Okay.
and the p-value was
Is that? Oh yeah. That's during the
late
35
meals.
hour test,
Yeah, yeah.
37-hour test. Okay.
Uh, okay. What I was gonna say, and the p-value was 0.001, and the an average glucose concentration decreased by 0.27, plus minus 0.05 units, and the p-value was lesser than
But,
0.9.
so the average glucose level went down when they
The,
skipped breakfast.
no, we're talking about late meals.
Yeah, I mean, like basically, they wake up and normally they would have breakfast, but in that case they waited 5 hours and they basically just started lunch, dinner, and late dinner.
Yeah, yeah, yeah. Well, then yes. In adipose
Basically, yeah,
tissue, um,
okay.
PER2 mRNA rhythms were delayed by 0.97 plus minus 0.29 hours. And
What is that?
okay, the mRNA rhythms were delayed.
Oh yeah, that's a question for you for tomorrow. Is which ones?
Yeah, yeah. Yeah, I think you told me that question yesterday.
Yep, yeah.
Um,
Just remember to look into it.
yeah, yeah. Okay, so they were delayed by 0.97 plus minus and 0.29 hours, and the p-value was lesser than 0.01, and it indicates that the human molecular clocks might be regulated by feeding time, and they could underpin plasma glucose changes. Time meals um, therefore play a role in synchronizing peripheral circadian rhythms in humans and might have a particular relevance for patients with circadian rhythm disorders, shift workers, and travelers.
I mean, I wonder if like it was delayed by 1 hour as far as like both like when they get sleepy, when their melatonin, goes down
Hmm.
or goes up, peaks, and also when they wake up, which is when their cortisol is goes up. Like if both are basically going to sleep and waking up was delayed by 1 hour.
Mm.
Uh, but I mean, if it said that the sleep, quality wasn't affected, that's basically what it means is that they still got the same sleep. It was just shifted by an hour.
Yep,
Which
basically.
who cares? I mean, as long as as long as they get all their sleep and and it's the same quality, like just plus minus 1 hour.
Yeah, it's all it matters.
Okay. Yeah,
Uh,
that's pretty amazing. That's a pretty amazing. That basically means that it doesn't matter when you pick your feeding window. Like it can be later or earlier. And in fact, like almost what it almost suggests is that if you eat closer to sleep time, you'll get better blood markers,
yeah,
which is something that you don't hear people say. People say you want to not eat before sleep.
yep. That's what I've been
Okay,
told.
cool.
Now I'm
Yeah,
gonna
I mean
talk.
this study basically says you should eat before sleep and not after you wake up.
Yeah.
Okay.
Nicotinamide riboside. It's like a supplement that I digged into. Do you know about it?
Was it an R or is it an amendment?
It's NAD.
NAG. Oh yeah, I mean both, like I guess
Yeah,
an R and a man
yeah. They convert
convert
to
into an AG.
NAD. Yes, basically.
Okay, yeah, yeah.
Okay.
Yeah,
Uh,
I've heard a lot about it,
well,
but let's hear you out.
it's converted. Well, basically, nicotinamide riboside. When it's consumed,
NR.
it's consumed into NAD plus through a series of enzymatic reactions. The first step is a conversion of NR to nicotinamide mononucleotide or NMN.
And the man.
Yes, which is then is converted into NAD plus by nicotinamide mononucleotide adenylate transfer or NMNAT. NAD plus nicotinamide adenine dinucleotide is a coenzyme that is involved in several biological processes in the body, It is essential for the transfer. Bleh. It is essential to transfer the for the transfer. Bleh. Wait,
Wait,
let me put on my
wait.
glasses. One.
Okay.
Wait, what were you gonna say?
What? I'm so I so NMN. Okay, so what does NR stand for?
What do you say?
What does NR stand for?
NR.
What? Yeah.
Um.
Um,
Fuck. Let me remember.
like the two words. What are
Uh.
the two words?
Uh.
I feel like you just read it.
Yeah. 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 Yeah.
like 8 seconds ago.
Yeah. Yeah. I think I'm trying to remember. Yeah. Yeah. It's nicotinamide mononucleotide. Yes.
Mononucleotide
Yes.
or mononucleotide.
Yeah, mononucleotide. Sorry, sorry. I'm looking at my glasses while I'm like thinking at the same time. I cannot find my fucking
Oh
glasses.
yeah.
I'm not even looking at the screen. I don't know where they are. I'm looking at my drawers. Uh,
just zoom in, zoom in on the fucking
yeah.
document. Um,
Give me a second. I think there might
let's
be on
see.
my bed. Can you wait a little bit? I'm gonna pause it.
Yeah, yeah. There should be an R,
Yeah,
something
yeah,
that starts with an
yeah.
R.
My bad, my
But
bad.
okay, what's an amendment?
NMN
Oh,
stands for
what's
okay, nicotinamide mononucleotide, is NMN, and the nicotinamide riboside is NR.
wait. So what an amendment stands for again?
Nicotinamide mononucleotide, and NR for nicotinamide riboside, riboside.
Mononucleotide.
Yes, mononucleotide.
Oh, wait. Nicotinamide mononucleotide
Tide. Yes,
and
NMN,
amendment.
and NR,
Okay,
NR
so
is nicotinamide
what
riboside.
is it?
And they're basically, you know,
Okay, so question for you is question for you is what is um nicotinamide and what is riboside?
okay.
Or that's what it said, right? Riboside, nicotinamide, riboside, something else.
Yeah, yeah. Okay. I have what is NAD plus.
What each of those two words mean?
Yeah, yeah, for sure.
Wait, wait. I'm trying to finish off this like investigation slash question. um, so yeah, what those two words exactly mean? Each one of them for the
Yeah, yeah.
NR and for NMN. Didn't we look into
NMN, yes.
nucleotide?
Yeah, yeah. We did.
No. Like, didn't we look into so nucleotide was like a piece of like check me if you can, but nucleotide was one of the four pieces of DNA. I think there's like four letters that DNA is made
Yeah.
of, and each one is a nucleotide. And so there's like four different nucleotides that DNA is made of.
Yeah, I believe so, yes. Yeah, I recall, yes.
And for some fucking reason, and so yeah, I mean, let's write it as another question,
Okay.
as a separate question. So a nucleotide. So DNA is made out of four different nucleotides. Is that true?
Okay.
Did you write that question down?
Yeah, yeah. Uh, 1 second. I can just,
Okay.
I can, all right. So NAD plus nicotinamide adenine.
Or how many or how many different how many
How many different one?
Okay, so what does the NMN stand again for? Stands for
Nicotinamide
what does the
mononucleotide.
NMN stands for again?
Nicotinamide mononucleotide.
Nucleotide, mononucleotide,
Yes.
mononucleotide.
Uh,
Oh yeah, yeah, mononucleotide. Nicotinamide. I don't know if you can just like look into why is it called mononucleotide as you
why
know,
is it called mono?
and
Okay, yeah.
or like what is mononucleotide?
Okay, for
That's,
sure. Uh,
if you don't find a clear answer why mononucleotide is part of the name of NMN, then at least like what is it?
okay,
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 cool. Okay, yeah, that was my question.
okay. Now NAD, nicotinamide adenine dinucleotide, is a coenzyme that is involved in several biological processes in the body. It is essential for the transfer of electrons from one molecule to another during cellular respiration, which is the process that produces energy in form of ATP. NAD plus also plays a role in DNA repair as the sole substrate for the nuclear repair enzyme polymerase, and additionally NAD plus is required for the activity of the sirtuin family of NAD dependent histone the deacetylases. No, how do you pronounce it? Deacetylases. Therefore, NAD plus is involved in various critical cellular functions, including energy production, DNA repair, and genomic signaling. Um, PARP stands for, poly or ADP ribose
Can
polymerase.
you read the sentence?
Which one? Which one?
That really big sentence. Well, mostly about the DNA repair part. The part where you
Okay.
say something about DNA
NAD
repair.
plus is involved in various critical cellular functions, including energy production, DNA repair, and genomic signaling. Do you know um, what is genomic signaling? Uh, I learned that. Can you hear me?
I sort of know.
Okay.
It's just when um, genes basically. Yeah, yeah, yeah.
Yep.
I think it's when genes basically signal to make different proteins.
Yep. Um, what I was gonna say, PRP stands for poly-ADP ribose polymerase. It is a nuclear repair enzyme that uses NAD plus as its sole substrate. This enzyme is involved in repairing DNA damage by adding uh, uh, polymers to target proteins. The study found that as age increases, PARP activity increases, leading to depletion of NAD levels, which play a critical role in the aging process by limiting energy production, DNA repair, and genomic signaling. Yep. Um, this study investigated the association between NAD levels,
Weird.
aging, and various
Okay.
biological processes in human tissue. This study analyzed pelvic skin samples from 49 patients ranging in age from neighbors to, newborns to like 77 years olds, and the results showed that DNA damage correlated strongly with age in both males and females, while lipid
Wait,
oxidation
wait,
is.
wait. What
I'm gonna repeat it but slower.
what
The
skin?
uh what
What skin they analyze?
pelvic skin.
Pelvic?
Mm-hmm.
Pelvic skin?
Yeah,
Pelvic skin
yeah.
from the crotch. They took skin from the crotch
Pelvic
of
skin
fucking babies and
samples.
all. And, okay. Okay. If you can start from there.
This study analyzed pelvic skin samples from 49 patients ranging in age from newborns to
Yeah.
77
And
years
then what?
old. Results showed that DNA damage correlated strongly with age in both males and females. While lipid oxidation levels increase with age in males, but not in females, PRP activity significantly increased with age in males and was inversely correlated with tissue NAD levels. NAD levels are also decreased with age in both males and females, and CRT activity negatively correlated with age in males, but not in females. This study found hyperactivation of PARP2 oxidative damage to DNA during aging might be responsible for increased NAD catabolism in human tissue, which can limit energy production, DNA repair, and genomic signaling, and it might play a role in aging process. Um, okay. Nicotinamide riboside.
Are you there?
Yeah, wait, didn't you hear what I said?
Hello?
Hello?
Where? Did you just pause?
No, I didn't pause. I was speaking. Can you hear me?
I there was like a couple second. Yeah, can you hear me?
What's the last thing you heard me say?
Oh no, I had a couple seconds pause. Yeah, I had a couple. I can hear you now. I
Oh,
had
can you hear me?
uh, something. I mean, I go back like two sentences. Can
Okay. This
you hear
study,
me?
yeah, can you hear me?
Hello?
Can you hear me?
Hello?
Um, what I was gonna say? An SIRT1 activity negatively correlated with age in males, but not in females. An SRT1 is basically a protein that is activated by NAD, and it helps with uh, your metabolism and what was it? Um, Oxidative damage, DNA repair, and all that we mentioned before. Um, the study found that hyperactivation of PRP, which already explained what's PRP. It's it's a polymer. It's very basically polymerase. It's a nuclear repair enzyme that uses NAD. Anyways, so the study found that
I mean, that's pretty important.
yeah, yeah. The study found that the hyperactivation of PRP due to the oxidative damage to DNA during aging might be responsible for increasing NAD catabolism in human tissue, which can limit energy production, DNA repair, and genomic signaling, and might play a role in aging processes. So, yeah, basically, as you are aging, you produce less fucking NAD, and I mean NAD, yes, and your body starts breaking down more NAD than like synthesizing it. So therefore, you have lower levels of energy. Your DNA doesn't repair as much, etc. Um, Nicotinamide riboside on brain cells found that supplemented nicotinamide riboside increased levels of NAD in the brain of mice. This study showed that oral administration of nicotinamide riboside resulted in a significant increase of NAD levels in the brain by 42% compared to control mice that did not receive the supplement. And this study found that supplementation with nicotinamide riboside improved cognitive function and reduction of markers of oxidative stress and inflammation in the brain. Um, that's what I found on regards of studies to the brain. And when it comes to like heart, nicotinamide riboside supports cardiac function and survival in mice lacking the gene encoding the mitochondrial carnitine shuttle. In a study, mice lacking the gene of mitochondrial carnitine shuttle were supplemented with an NR, which will be the supplement that we are talking about, nicotinamide riboside. Um, the results showed that NR supplementation improved survival rates by 40% in the control group versus 80% in the NR um, versus 80% survival in the NR treated group. And cardiac function as measured by left ventricular function. The study investigated the potential therapeutic benefit of nicotinamide riboside and NR on cardiac function and survival of mice with disrupted circadian clocks in their in their cardiomyocytes. The researchers used a genetic approach to induce a disruption of the cardiomyocyte clock and administer NR to mice through their drinking water. The
Wait. There's a cardiomyocytic clock.
yes,
Mm,
I remember reading
Myo.
about what it is, but I forgot about it. I did read what it was. Um, but yeah, I forgot to like.
Yeah. If you write that, that's another question. What the fuck is
Yeah,
that?
for sure. 1 second. Let me 1 second. I'm gonna pause it. I'm gonna close the door. What I was gonna say. This study investigated potential therapeutic benefits of nicotinamide riboside on cardiac function and survival in mice with disrupted circadian clocks in cardiomyocytes. The researchers used genetic approach to induce the disruption of the cardiomyocyte clock and administered nicotinamide riboside to the mice through their drinking water to assess the effects of nicotinamide riboside on cardiac function. The researchers used an echocardiography to measure left ventricular ejection fraction, a parameter of cardiac function. They observed a significant improvement in left ventricular ejection fraction in the mice treated with nicotinamide riboside compared to the control group. The improvement rate was approximately 20% in the nicotinamide riboside group. The research also evaluated the effect of NR treatment on survival rate in the mice with disrupted cardiomyocyte clocks. They found that NR treatment prolonged survival in mice with an approximately 30% increase in median survival time compared to the control group. The researchers used survival analysis to calculate the survival curves and compare the difference between groups. And they assessed the effect of NR treatment on cardiac fibrosis, which is a common pathological feature of heart failure. And they found that nicotinamide riboside treatment significantly reduced cardiac fibrosis in the mice, which suggests that NR has a potential therapeutic benefit for heart failure.
So was that another question? Was that or did it reduce that fibrosis before or after the damage?
I will write it down. Okay. Uh, I'm gonna stop it to start with the we're just gonna say the statistics presentation. L-tyrosine is a type of amino acid that is essential to the body's function. This amino acid is unique because it is both a building block for proteins and precursor for several important neurotransmitters. L-tyrosine is found in many natural sources such as meat, fish, dairy products, and grains. It is also available as a dietary supplement in a capsule, tablet, or powder form. Many people take L-tyrosine supplements to improve their cognitive functions, reduce stress, and improve mood. One of the primary benefits of L-tyrosine is its role in the production of neurotransmitters, including dopamine, norepinephrine, and epinephrine. Epinephrine. These neurotransmitters are essential for regulating mood, stress response, and cognition. Studies have suggested that L-tyrosine might be beneficial for people experiencing stressful situations. X. Imagine you have a group of data points about health and you want to find the average of all these points. This average is called the mean and it's represented by letter X. In a normal distribution, the mean represents the center of data and the majority of the data points gather around it. To solve for X in normal distribution, you will simply add up all the data points and divide by the number of data points. It gives you the mean or the average of the data. Think of it like a supplement test. If you want to find the average score of a supplement, you will add up all the scores and divide by the numbers of health indexes. This gives you the mean score of the supplement, which is the average score that represents the center of the data. And here we have the data, the gathered data of L-tyrosine, and the formula that we use to come up with the t-value was the t-distribution. um, you know, it's basically the same like as the C distribution, um, or like very similar, but you use the t-distribution when you have like the sample standard deviation and not the standard um, not the standard population not the standard, not the population standard distribution. um, and usually it's better to use it when like the student distribution when there is like less than like I don't know five or not five like less than 30 uh um sample
Data
quantities.
points.
Yeah, sample quantities. And what I was gonna say,
So what's mu equals 0.059? How did you calculate that?
uh that's like like I told you in the past, like average previous days where you didn't take it.
Okay.
And then like basically once we came up with the t value, our conclusion was that um you
And
know
then t value. Wait, and then for t value, you the x, the x is the average of health indexes after I taken L-tyrosine, right?
wait, on held the x, you mean like the sample mean of this formula to come up with the t value?
Yeah, that x of that equals
That's the
minus zero
average.
point one six seven.
Yeah, that's the average of you taking uh what is it called, L-tyrosine for
So that so that's seven health indices after the 7 times I taken L-tyrosine average of
yeah,
those.
like the hypothesis mean is like the previous 7 days, like I did with Corona and Modelo, and the sample mean is like the 7 days, which will be like the 7 samples of you taking the supplement. And then the distribution, I just did the formula, I got it. Then I used like the formula where you solve for x to find the x critical value. And you know as
Okay.
you
Oh,
you basically so yeah, you seem to know like the formula basically. You divide the standard sample mean by the square root of your number of samples, and it will be like the result. And then if you divide, you know, uh, both um, numbers by the denominator, it will be like, basically irrelevant, because you don't really need those numbers regardless if you do that. So you just like cross it out, and then you basically um, multiply that result by your t-value, and then you come up with this value, which will be negative 0.225, and then you add up the hypothesized.
Uh, so this doesn't make sense. Let's see. So here the T critical is like 0.5.
Mm-hmm.
Is that something you calculated somewhere? Yeah, yeah.
The
But
critical value.
or actually, yeah. Did you calculate somewhere T critical?
I use like the chart.
Yeah. So from the chart, what's the T critical?
I don't have the chart here on hand. Can you like check it out for me, or like do you want me to pause it?
So no. So from the graph, it looks like the T critical is like 0.5, right?
Yeah, yeah. But like,
So basically,
hmm
so basically, uh, our sample T value, our L-tyrosine T value is really far from the T because the sample T value is on the left of 0. It's like negative.
mm,
And then the T critical is 0.5, which is on the right of 0, right?
yeah, yeah. So I might have messed up with the the critical value, but I checked it on the okay. But like, how can I explain it? Regardless of the t critical value being wrong, that does not affect like the formula used to get the t value, or the meaning of x, because the t critical value, like, is just basically, you know for like the degrees of freedom, which will be 1 minus your sample size, which will be 7, and then the result will be 6, and then you use like your alpha, and then you looked up the number of n, or like your degrees of freedom and the alpha, and that's your how you come up with your critical value. So I mean, maybe I fucked up with that, but that does not interfere with the rest of the formulas that I did.
So what you're saying is the X critical is correct.
The what? The d critical?
The the X critical is not correct.
No, it's correct, because the t critical value does not interfere here, because we're using the t distribution, not like here. We're using the t value, not the t critical value. Like,
But you whether you reject or accept, it depends on if the T value is below or above the T
yeah,
critical,
yeah,
right?
yeah, yeah. But like, these two things are different. Like, do you see this here? Like this here, t value. That's
Yeah,
the t
yeah,
distribution,
T,
and this is the t
yeah,
critical value.
yeah. T value is the T value of the sample after I had taken L-tyrosine of that sample.
Like, no, well, this chip value is pretty much like the formula of like getting like the deep value, which will be not this one. It's basically like the C distribution, or like the standard distribution formula, which you use it by getting. Yeah,
Oh.
yeah, yeah. So this is not correlated. This not does not interfere with any of this. So this is correct. This is correct. If I fucked up with the t critical value, is completely irrelevant or unrelated to this,
Yeah.
because
So I guess the T1 is in the wrong place. So your T value is. Oh no, it's not in the wrong. It's in the right place. Wait, what?
yeah, yeah, the
T
like
critical is
yeah,
positive.
yeah, here we're like the
Uh,
everything is in the right place, I believe, but
Well, I mean, it kind of looks like the T value is where it should be, and the X critical is what's is
No,
not
no, no. Look,
correct.
look. T value, right? The like the T distribution, right, is here.
Yeah.
T1, right? And the formula that I did and stuff like that is correct, like this. And the X critical value is fine. The only thing that there is a chance of being wrong, which doesn't really matter that much, will be the T critical value. But yeah, that's it. Anything is wrong, it will be the T critical value. The rest, 95%, 99.9% sure that is correct.
Um. So let's see. T value.
The crit they're
Uh,
different. The T value and the T critical value are different. It's like the T distribution, the T value is a T distribution, and the T critical value is different. That you do not need any of the data in
but
here
that's
besides
but that's what
degrees of
that, that,
freedom, which will be 7 minus
that
1, and then the alpha, which will be zero point
but
0.3.
that's the most important thing that we use to like accept or reject is the T value and where it lands compared to the T
No,
critical, right?
I mean, sort of, but like you can just basically also tell by the what is gonna say, uh, um, the chart itself. Like, yeah, but I'm pretty sure this is. I mean, if you look at in the chart, like the numbers, right? That's the number that it gave me.
Okay.
But yeah,
Um. Okay. That's fine.
is it wrong? The critical value?
No, I just have to stare at it for a bit to like figure out what's going on. Uh, because
Uh,
like I don't understand that equation like
this one,
as
the
far
X
as
one.
well because like you use that equation to calculate t, and then you plug the t back and use that same equation to calculate x, right?
Oh yeah, yes, yes, yes. But like here is to, for example, let me explain you the X one. So basically, right? If let me put it this way. Let's say you have like your 7 samples, right? Or like let's put it in a bigger scale, so it's more understanding. Like let's say you have like 100 samples, right? Okay, of like, and each of them is like a particular day of your health index. Okay, you get it? Like so far?
Yeah,
Okay,
yeah.
okay. And let's say the average, uh, it's how can I put it? Well, not the average. I'm sorry. Um, one of those samples of your health index, right? It's not negative 0.166. That will mean that it does not correspond to, like, what the average sample should be, right? Which means that if it goes past the X critical, that sample does not follow like the norm of your average fucking day of taking L tyrosine. You get it?
You mean one sample out of 100?
Yeah, yeah, like any, like if any of those samples do not have a fucking value, like I'm not we're not talking about the samples as in like group, or like a sample. I mean, like we're talking about like one sample. If that sample, right, has like the same like standard sample standard deviation and the same alpha, right, as the one used in this formula, in this equation, and it has a fucking different value, or like it has like a um higher value than this, that means that that sample you know does not correlate to like the average standard for your health index of taking L tyrosine, which in that case, if if we're talking about like a product or whatnot, it will be rejected. Or here also it will be rejected. Like it will be an odd fucking sample.
Yeah, but I mean, it's just one. Like you have to look at the group, right? You can't just look at the single, one of the samples. You have to
Yeah,
like
yeah, yeah, yeah.
take them
Of course.
together.
Yeah, yeah. No, no. But I was just putting in this example. I was putting on practice where I learn about the X critical value.
Oh, okay.
Like this not fully interfere with like your health, and it's understanding that we are working on different circumstances. But I just wanted to show off that I know how to get the X critical value and I know what it means.
Yeah.
Yeah. And here obviously the t value is t1, so healthy, you see, non-rejection zone.
Okay. So okay. Well, I mean, if the critical value is minus zero, or the critical value is 0.7357, why didn't you plug that into the for the t in the second equation?
uh Wait, in this equation, in this formula?
Yeah, why did you use minus 0.562?
Because the t value
Uh,
and the critical value are different.
yeah, but if you're trying to calculate x critical, you want to use the t critical.
No, you want to use the t value. You don't want to use the critical. Like if you're watching the videos, for example, when he uses like the c1, he uses the value of c, like the not the critical value. You don't use the critical value. You use like the result of your formula that will be. uh Give me a second. I'll show you. Yeah. Okay, so you know I
You're
made a
not sharing the
mistake.
screen.
Oh, okay, so I made a mistake and I'm gonna correct it tomorrow. I used the T score instead of the T critical value, and I'm sorry. I have failed myself, Panda, and all of you.
Yeah, I hope all the people who protect pandas will be very upset.
Yeah, and yeah, basically, and here I wanted to explain also, like, I mean, well, this T1 value is still valid, like, regardless, it's still value. Like, the closer
Yeah, yeah,
it
that makes
gets,
sense.
to the what is it called? To the reaction zone or alpha, the higher the likelihood of us rejecting or null. And same here, like another example, if we had like a 25 percentage confidence level and a 75 percentage alpha, it will be rejected. But since we are not, we're using like a 70 and like 30, uh, it's not rejected, and that's
Wait,
it.
wait.
What?
So the t critical here is minus 0.74,
Yeah.
and the t value is within the rejection zone. Wait, what?
Yeah,
Yeah.
yeah. No, because this is just like examples of like, how if we have a greater rejection zone, the likelihood of being rejected is higher. Like this is just like, we're using like 75 percentage rejection zone. And if we look at here at zero, it's neutral. Like, and the, t value is negative 0.572, which is healthy. Here I'm just displaying how, like, trying to show how the bigger the alpha, the higher the likelihood of your null hypothesis being right. You get me?
Um, let's see. So I feel like they should be swapped now. I feel like the t has to be to the left of that zone.
The T1
For
is on
it
the
to
left.
be. Yeah, but I feel like it should be to the left of that grayed out zone for us to say that L-tyrosine is, we're 75% sure that L-tyrosine is healthy.
But like here, even if we use like 35 percentage confidence level and a alpha of 75 percentage is still healthy. Like zero is neutral.
Oh, so you're saying that it's to the left of the gray zone up until
Like
like
all this area that we see here,
65
yeah,
65%.
yeah, 65 percentage is unhealthy. The rejection zone, right? Which our null hypothesis is basically it's healthy. The alternative hypothesis is unhealthy. You know,
or neutral.
yeah, yeah, or neutral if it lands on like zero or yeah. Uh, so like
Okay, so basically we're about 65% sure that it's healthy and it's not unhealthy or neutral.
yeah, yeah, because landed on like
But
negative 0.562.
so like if we wanted to use a 70% um, confidence level,
Yeah, it's here.
then we wouldn't be able to reject it, right?
Yeah, not even in the even only having a 35 percentage confidence level, it cannot be rejected.
Right. Okay. Okay. Makes sense.
Yeah,
Nice. Nice.
yeah. All right.